Hey everyone, welcome back to Tech Junior Tutorials. My name's Lee Warwick Jr., and we're talking about Advent of Code. So today is the 23rd. I just finished day 19. It took me a little bit longer than I was hoping. I was really hoping that I'd get it done first thing in the morning and only spend like an hour on it. Ended up spending some time this afternoon on it as well. So let's take a look at it. For day 19, this is Tractor Beam. It's running again on the Intcode program. So it seems like every other day now we're doing something with the Intcode computer that we programmed and finished on day 9. So if you're curious about those videos, I think it starts on day 2, and it's like every other day up to day 9 is actually building features into the Intcode computer. But for today, they tell us you've got a Tractor Beam, and basically for part 1, they're just saying that the grid is a 50 by 50 area. So they even help you out and say, like, for X and Y, you're going to iterate from 0 to 49. And they just want to know how many points are actually in the grid affected by the tractor beam. So they want you to count the hashtags. What they tell you is that for your Intcode program, first it will request a X, and then a Y, and then it will output either a 0 or a 1, letting you know that for that XY coordinate, whether or not it is affected by the tractor beam. So this threw me for a loop first thing in the morning because I had thought that it would continue to call and ask for coordinates and just like run in a continuous loop and output 0 or 1 for the whole thing. So I was like banging my head this morning against the desk wondering what was broken, but basically you have to run the Intcode computer once for every coordinate set that you need to do or need to check. So after working with like all the mazes and stuff and some of the previous visualizations that we worked on, visualizing this and working with this grid system was like a no-brainer. Getting that part done was really fast. Most of the challenge for part 1 was getting Intcode to actually work with my code. So let's check that out. So I've got my Intcode computer collapsed along with its helper function. And our input is just a big array of numbers for the Intcode computer. So I've got some helper functions to help me print and visualize this, but you don't actually really need them for the answer. So I start with making an actual grid that is full of dots just for visualization. I make a method to actually print the grid, which I've like reused this code over and over and over to do all these visualizations for the previous puzzles. And then for my actual int code, I make a input function and an output function that I pass into my int code function. And for the input function, it is going to basically flip between returning an X value or a Y value. So I start X at or Y at 0, X at -1, because each loop I'm going to iterate increment by 1. And then if I hit 50, so I don't want to jump to the next row from the start. I want to jump to the next row from when I finish the first row. So I say if X is not 0, and if X mod 50 is 0, meaning I've hit 50, go ahead and add 1 to Y, so I'll drop down to the next row to check. And then whenever I return a value, I always mod 50 because X is going to kind of be like my counter that's just going to count the number of points that I'm checking, and it's going to count upward indefinitely as long as I keep asking for points to check, and the same thing with Y. So using the mod 50 trick just kind of helps me not have to worry about wrapping that X to the next row or resetting it and having like a third counter or something like that. I've got a global counter just for how many beam hashtags I've counted. And then my output function takes in that 0 or 1 value and then looks at the global counter for hashtags. Then it says, hey, if you got a 1 back, go ahead and increment by 1. and set the grid at my current XY to hashtag and then print. And then here is what actually took the most time, running int code over and over again to check every point. So I would run it and it would check one point and stop. And I was like, well, what's going on? Am I supposed to run it over and over? And so I would do this and pass this in. And for whatever reason, like I've been coding for not since yesterday, but you know, a good over a year, almost 2 years now. And I guess I've never run into this before, but basically I was doing a pass by reference by passing this array of inputs into int code. And what int code was doing was actually mutating it, which I didn't realize right away. And the other days that I've had to use int code, I think I only came across this once and forgotten about it this morning. So I had a sneaking suspicion that making a copy of the array would solve it, and thankfully it did. So I just loop over the array. Sorry, not the array. Loop over all possible positions, and for each possible position, or loop over the amount of possible positions. And for each one, run the encode computer and update my grid. And that's it. So most of this code, like at least a good portion of it, I guess, is actually visualizing this. So let's check that out. To make this a little bit smaller. Oh gosh. Let's go ahead and restart git bash. So you can actually see as the hashtags appear that I'm checking from left to right, top to bottom, and just looping over this grid and counting every time that I hit a spot that's in the beam. And then I've got a counter at the bottom to just let me know, you know, how much, how many beam spots that I have. So this was a little bit weird. The I guess the tractor beam, they tell you that 0, 0 gives you a a beam spot always, but the actual beam itself doesn't start until like position 4, 3. So x of 4, y of 3, and then it actually comes down. So that one was not too bad. 231 was the answer that I was looking for. So I was pretty happy with that. There's that 231. But for part 2, I got tripped up. So here's what happened. They say that, I guess this tractor beam, you're going to use it to get Santa or something. And so his ship, you're guessing, is 100 by 100 in size. And so they say that the beam is like this conical shape. It's not a perfect cone, which we can see here. It is actually like, at some points, like this is 3, and then 4, and then 3. So it gets like wider and smaller in spots. It's shifting to the right progressively. And by the time we're at the bottom of the grid, like down here, the tractor beam is like totally off screen. So they say that you want to find Santa's ship. So this is a 10 by 10 example. Basically, they want to see like what the top left corner is, or what position that would be where a 100 by 100 square would fit entirely within the beam. What's the first one? And so I kind of went with the naive solution, which was, hey, why don't I just iterate, like, just keep going until I count 100 or something. And right away, what I found was that as this thing increases, you can see, like, as it's getting wider, imagine the right side of this over here is just like also getting wider. So if you've got X and Y expanding into infinity, obviously that is now, much like many other problems in advent of code, becoming a problem of exponential increase. So like, I wish I had looked up like the big O numbers or like logarithm or whatever, but basically your complexity is increasing exponentially, so your compute times are doing the same. So we're doing like these loops that are getting bigger and bigger and bigger and bigger, and doing nested for loops over that. So that quickly slows to a halt. So if I had saved the code from earlier, you would see that as you count hashtags, the code runs slower and slower. So like by the time you get into the hundreds, it's ticking like one or two at a time, or like one row every second or 2 seconds, and just getting worse and worse. So that kind of told me that, okay, I need to do this differently. And so I had switched my strategy from checking the left side of the beam to the right side of the beam. And so I would check here, and then I would check the outside. But because the beam, so like each row I would, I think, increase by 1. So I do like 1, and then check x plus 1, and then there, x plus 2, x plus 2, like x plus 2, and then hit a space, and then go, okay, so my maximum is 3, so next time go ahead and jump immediately to 3 and check, jump to 3 and check. But the problem was that like here, actually, I don't think they show it in this example, but in the actual beam, we can see it where like here we'll hit 3, and so for 4, I would jump down like that spot and look 4 ahead and completely miss the beam. So that was a headache right away. And then also I was doing this thing where I was trying to check like, okay, count these until you hit one that is at least 100 wide, and then also check like 99 places down. And if the top left and the bottom, if it's 100 wide, you're at the edge, and the bottom left is in, like that would be the square that we're looking for. So like there and there and there, if those 3 points are in, we don't have to worry about that fourth corner. So I was checking here first, like as I went down, and then I needed to like move inward, but my code was just getting like really wacky, and so I was trying to do like a bunch of weird algorithms and stuff until eventually I had to stop and then think about it. And what I came up with was basically a pseudocode algorithm for this, which I wrote down in this notebook. So basically how this works is I would loop the x value wherever I'm at in space until I hit the beam. And if you notice, like we don't have to check all this space over here. This is always going to be empty. So there's an optimization there where you can say like, okay, here's my previous x, go ahead and drop down to here and then start checking. Drop down to here and then start checking. And that shaves off a little bit of time too. So start at x and then move 100 places or 99 places to the right. So I would check x, and I would check like way over here and see if it's in the beam. And if not, I would jump down to the next row until I hit a spot that was 100 wide. Then once I hit that, I go ahead and check 99 rows down at the same x value as the top left coordinate and see if that's in. So if that's not in, so like let's say here is 100, then I would jump down and say like, okay, let's say this is 100 rows down. So I would then say like, okay, nope, that's not in. Then I would move to this value and check again. Hey, is this value over here inside? If it is, check from that value down to 100 and check if that's in. And so I would do that until I hit empty space over here and then drop down a row. So that algorithm is what I ended up doing in the end. And then I also rewrote, I basically trashed my code from part 1 and just completely rewrote it. Thankfully, this is a small enough problem that I was able to do that. So for part 2, completely got rid of the code, so started fresh, and I just wrote a function that is going to call encode for me, take a set of XY values, and return true or false whether or not it's in the beam. So the way I do that is kind of tricky. It's not something that I would. It took me a while to get this down in JavaScript, and so I was happy to be able to make it work in Python. It's still kind of sketchy in my mind, but basically what I'm doing is I've created a function that's going to wrap int code. So it's going to take an x and y in, like I said, and so we store those as a list, but backwards, because I want to pop the results off the end, because it's going to ask for x and then y. And so for my input, I'm going to define this function within this other function, and that is going to create a closure over the coords array. So when intcode calls inputter, the first time it calls it, it will get x, and the second time it calls it, it will get y. So that greatly reduced the complexity of the input function from the part one. And then for output, I've got a beam result variable out here, and I say like, okay, that's a non-local. And then whatever they pass in, I just set that to the value in the outer scope. So that's another closure that I'm creating. Actually, I'm not even sure if that is a closure, but it is a scope complexity problem that you probably wouldn't deal with every day. But basically, this reaches out to here, sets that value, because encode doesn't return anything except done, at least my version of it. And then I say, hey, if the beam result that I got from encode is 1, return true, otherwise return false. And basically I've abstracted away encode completely, and I just have a function that has an x and y input value, and it returns true or false for whether or not I'm in the beam or not. Then I start at 50-50 for x and y, and the reason I do that is because from this first example, we're working with the same beam, and so this is a 49 by 49, or 0 through 49 by 0 through 49 grid, meaning that that point right there is 49, 49. So I want to check 1 over and 1 down from that. Basically start there. I'm almost positive that that is not within the tractor beam based on the trajectory of this thing, considering it's shifting further and further right. So I figured that was a decent point to start without doing some kind of fancy math to figure out, like, you know, a better point. So that shaves off a little bit of time, not having to check the first 50 rows or 49 rows of this. So that helps a little bit. So from there, what I've got here is basically that exact algorithm that I just talked about. So while I haven't found that that top left square, or the square's top left coordinate, which is the puzzle answer, right? So that coordinate. Go ahead and look at my current XY. If I'm in the beam, look or save that that coordinate, which would be the top left, and check 100 places to the right, or 99 places to the right, because the ship is 100 wide. And so that returns a true or false. If that is in the beam, then I'm going to look at the bottom left, so look 99 places down from y's value. And then if that is in the beam, I've hit my first point that can fit that 100 by 100 square. And so I switch to true, which stops my outer for loop or while loop. And then I print the final answer. And then this will actually keep running. At least the while loop will, for a little while longer. I should probably throw a break in there, just for giggles. Doesn't really affect the complexity because it's only going to shift over a few more places. So anyway, if I don't detect the beam, go ahead and look further right. And if I have not hit the right side of the beam, or I'm outside of it now, Go ahead and drop down to the next row, and X stays the same because it is not changing from the left side. So like if I'm here and it's out, I'm going to drop down to here. If it's here and that is out, I go ahead and drop down to like here and look. So it's a little funky to think about, but it works. So let's go ahead and run it real quick. So it's going to take a few seconds to loop through all these coordinates, and at the end, the very last part of the puzzle is it says you need to multiply your x value by 10,000 and add y to it, and that will be the final puzzle answer. So this is kind of a, there we go, kind of a not a naive solution, but it takes a few seconds, so I'm sure there's better ways to do it where, like, you know, the people on Reddit that get this in like 2 milliseconds or something have got some kind of crazy optimization or some kind of like fancy math to calculate like, okay, well, this thing like increases a certain number of values as you go or something like that. I just decided to use ink code and like run the thing until I could hit that first spot. So that is all I've got for this one. The final value, 9210745, is the puzzle input answer. So this one took me a little bit longer than I thought that it would, which was a little bit disappointing. But now I get to work on day 20, which is a crazy donut maze where you've got like an entrance AA and you're trying to find ZZ, and you got to move, find the shortest path, but there's also portals. So if you go to BC, you can pop out to BC on the other side. So that is going to be very interesting to work on. I'll be working on that one next. It looks like 20 is roughly twice as hard as today, so I don't know if I'll be able to finish it tonight or tomorrow. We'll see how it goes. Also, we're coming up on Christmas in a couple days, so the rest of the videos may follow. Really shooting to get these done by the new year. Hoping that the difficulty that we've seen for like day 18 is not as bad for the rest of them. You can see like 22 part 2 was even tougher than day 18 part 2. Looks like 22 part 1 wasn't bad, but part 2 is a real monster. We'll see how that goes. I'm hopeful that I can get it done. But looking at some previous years, looks like there's only in any given year a few puzzles that are like absolute nightmares. So it looks like 1 for 2016. So we've had 2 so far. I'm hoping the rest of them are kind of hovering around this lower level. But we'll see how it goes. I'm just happy to still be hanging in there this far. So that's all I've got for today. Let me know how you're doing. Like, subscribe, follow us on Twitter at TechJR Podcast. Follow me at Lee Warwick Jr. And I will see you on the next one.